In this section, let's look at the sum to product as well as the product to sum formulas. Recall the sum and difference formulas for sine and cosine, as seen here. These were developed in the previous section. Now we can take these and combine them to give us an entirely different set of identities. We're going to starting off with these two, we're going to take these and we're going to combine them by adding them together. Okay? You say, well, why those two? Well, actually, you can use this two or these two or these two. You can actually pair them however you like, but we're going to start with these. So we say, okay, I'm going to take the cosine of A plus B, and we're going to add to that the cosine of A minus B. Okay, so we've added these sides together. That's the left side of our equal sign. On the right side, we need to add these together. Okay, so that'll be cosine A cosine B. This one right here. Cosine A cosine B minus sine A sine B. And then we're adding this row here. So plus cosine A cosine B plus sine A sine B. Okay, just barely got that in there. So here we've added the left side with the left side, and then we added the right side with the right side. Now you notice some terms cancel out. Here, sine of A minus B minus sine of A minus B, those subtract away. These are identical. Cosine A cosine B plus another cosine A cosine B, well, that's double cosine A cosine B. So cosine A plus B plus cosine A minus B is double the cosine of A times the cosine of B. Well, now what we can do, we simply divide this over. And we get the first of what we call the product to sum formulas. Here, this gives us the cosine of A times the cosine of B is equal to half. All I'm doing is I'm dividing the two this way. It's going to give me half of cosine A plus B plus cosine A minus B. And there's nothing special about combining those two. And in fact, there's nothing special about addition here. We could subtract. If you take any of these and combine them by either adding or subtracting, you're going to get a formula like this. We're going to do one more right here. And in fact, you might try it yourself. And I'm realizing I've made a mistake here in my sum and difference formulas. This one's supposed to be a minus. And here we go. All right, now let's see if we can try that ourselves. Go ahead and pause the video and give that a try. See if you can do something similar by, instead of combining these two, see if you can combine these two right here. When you do so, assuming it's done correctly, you should get something similar where you'll have, instead of cosine A cosine B, you'll have something that involves sine and cosine. So give that a try. Pause the video, see if you can combine these two in a way that I did here, and see if you can't isolate something about sine of A cosine of B. Once you finish that, go ahead and unpause the video and we'll go through it together. Okay, so we try these two here. By adding the left sides, we get sine A plus B plus sine of A minus B. And then over here, I'll add these two together. That'll be sine A cosine B plus cosine A sine B. And then we're adding this stuff down here. So plus sine A cosine B. Plus a negative, I'll just write that as minus cosine A sine B. And just like before, we notice a few things subtract out. Cosine A sine B minus cosine A sine B, that's 0. And these two are identical. So adding something to itself is just the same as saying, well, we just want double this. So this gives me the sine of A plus B plus the sine of A minus B is equal to double the sine of A cosine of B. And now divide the two over. So we get that the sine of A times the cosine of B is equal to 1/2 quantity sine of A plus B plus sine of A minus B. Just like that. And we can do the same thing by combining other ones. Instead of adding, we can subtract. And in the end, we're going to get what we call the product to sum formulas. Obviously named so because you start with a product, and these two are multiplied together, and you end up with sums. So here, let's go ahead and summarize those results. These are the product to sum formulas. Well, let's see. If you take cosine A, cosine B, that's equal to 1/2 of. And I'm going to go ahead and write this one first because, well, you'll see here in just a second. It's addition, so it doesn't matter what order we put it in, but I'm going to write this one first. So that's 1/2 of the cosine of A minus B plus the cosine of A plus B. Like that. And then if you take the sine of A cosine B, I'm just writing the two that we got already. That's going to be, and here I'm going to leave it in that order, 1/2 the sine of A plus B plus the sine of A minus B. And the reason I leave that in that order is because the next ones are easier to remember if we have a pattern going. So the next one would be sine of A, sine of B. And of course, you can always derive that by coming over here. Instead of adding these two lines together like we did right here, you would subtract these first two. If you subtract the first two, you'll get this one that we're about to write, sine of A, sine of B. And that's equal to 1/2 cosine of A minus B minus cosine, that's a minus sign right there, cosine of A plus B. And that's why we write that one with the minus first, because then these two are almost identical. All you have to remember is, oh, that plus becomes a minus to change cosines into sines. And for the last one here, cosine A sine of B, again, it'll be just like this one, except you'll switch a plus to a minus. So here we end up with 1/2 sine of A plus B minus sine of A minus B. So by writing it in that order, it makes it easier to remember. Basically, you remember these two, and then just remember, oh, to switch these, cosines become sines, sines become cosines. To switch these to their opposites, you just got to take that middle sign and flip it from pluses to minuses. Just makes it a little easier to remember that result. As a simple example of this, here we can write cosine of 3x times the sine of 4x. And right here we can write this product as a sum. All right, so I've got cosine of something times the sine of something else. So we're using this bottom formula. This will be 1/2 the sine of, we're going to add these two together, the arguments, the 3x plus the 4x, minus the sine of, and now same thing, but with a minus instead of a plus. So that'll be sine of 3x minus 4x, which is 1/2 of, what's sine of 7x minus the sine of negative 1x. And there we go. We write the product as a sum, or in this case, a difference. Sum or difference formulas. Go ahead and give that a try. Take the sine of 4x times the sine of 5x and see if you can't write that as a sum. Once you're done, go ahead and pause the video, give it a try, and once you're done, you can unpause and we'll go through it together. All right, so here, sine of something times sine of something else. We're using this third formula. So this would give us 1/2 of the cosine of, you would take your A minus your B, so your 4x minus your 5x. And then you would have minus the cosine of And then you would take the sum of those. So 4x plus 5x. And so this gives us half the cosine of negative x minus the cosine of 9x. There you go. One thing we could do here is we could simplify this just a little bit more. In fact, we could do the same thing up here. Remember that sine is an odd function, so if you leave it this way, that's correct. But we can do one more thing to clean this up a little bit. With an odd function, you can take the negative and pull it out. Right? Sine and tangent and cosecant and cotangent are all odd functions. So you can take this negative and pull it out. But since there's already a negative out there, that negative would combine with that negative to make that a plus. So here we would get half of the sine of 7x plus the sine of x. Either of these would be correct. Over here, we could do something similar, except that with cosine, unlike sine, you have an even function. And with an even function, you don't factor out the negative, you just ignore it. So here you can write this as half the cosine of x, because again, as an even function, the negative can be ignored, minus the cosine of 9x. And either of those would be correct. Now, while these formulas here allow us to go from products to sums, we can actually take these and basically invert them, have them go backwards so that we go from sums to products. You say, well, sure, instead of going from left to right, I can go from right to left. Well, that's true, but we can reformulate these to give us something that's a little more direct. So right here, and I'm just going to pick on the first one here. It doesn't really matter which one you use. You can use any of these. I'm going to take the cosine of A and the cosine of B formula here. So I'm going to say, okay, we're going to do something that's going to seem a little strange at first. I'm going to take A, and I'm going to take A, and I'm going to call it something else. So let A equal to U plus V over 2. Say, why on earth would you do that? Well, on its own, that's nonsense. There's no reason to do that. But we pair that with this. You say, well, that's still nonsense, right? Well, together they're actually kind of useful. Because take these and plug them in. You say, well, yeah, but now those look complicated. Right, those do. But what about these? If you do this, then A minus B is equal to U plus V over 2 minus U minus V over 2. Okay, well, right here, they have a common denominator, so I could just link those together. And I would get U plus V minus U minus V over 2. Here, my U's would subtract away. U minus U is 0. Here, the double negative becomes a positive, and I would get V plus V, which is 2V, over 2. And 2V over 2 is just V. On the other hand, if instead of subtracting them, you add them, you get something very similar. U plus V over 2 plus U minus V over 2. Again, they have a common denominator, so you could link those, giving you U plus V plus U minus V. And now instead of the U's subtracting away, now the V's subtract away, giving you 2U over 2, which is just U. So by using A equals to U plus V over 2 and B equal to U minus V over 2, yeah, we're going to make these look more complicated. But the trade-off is these are going to become much simpler. So if we do that, we end up with, I'm going to write this first. I'm going to have half the cosine of my A minus B just became V, plus my A plus B just became U, cosine of U. And that's equal to cosine of, well, now my A is this U plus V over 2. And this B is U minus V over 2. And finally, we're going to take the half and multiply it to the other side, and we get the first of what we call the sum to product formulas. And I'll leave a little room here because I'm going to do one more. So I'll put it down here, the sum to product formulas. All right, so the first of our sum to product formulas. I'm going to go ahead and write this one down. So I get cosine u plus cosine v. It's addition, it's commutative. You can do whatever order you like. So I'm going to write the u first because that'll make it easier to remember all the rest of them. They'll all have the same pattern of u and then v. So cosine of u plus cosine of v is equal to, we're going to move the 2 to the other side, so that'll be twice the cosine of u plus v over 2 times the cosine of u minus v over 2. And here you could do that same kind of substitution with any of our formulas from before, with any of our product of sum formulas. So here I think I'll just pick on the very next one, sine of a cosine b, and I'll do the exact same kind of substitution. I've got sine of a cosine b. Okay, well my a will be replaced by this, and my b will be replaced by this. So I'm going to have, let's fold this over so we can see it better. There we go. So we're going to use this substitution here. So we'll have sine of a, or a is our u plus v over 2, times the cosine of b, or again our b is our u minus v over 2, is equal to half of sine a plus b, we already know that's just u, plus sine of, and a minus b, we already know that's going to be v. Okay? And finally, you can take that 1/2 and subtract and multiply it over to the other side here, divide it over, and we end up with sine of u sine of v plus sine of v is equal to double the sine of u plus v over 2 times the cosine of u minus v over 2. And we could do this for any of them. Go ahead and give this a try. We'll do one more, and I'll have you guys try it. Go ahead and pick the next one here. We're going to take sine of a sine of b, and using this one along with our substitutions that we see up here, go ahead and give that a try. Go ahead and use these substitutions here and see if you can't create the next formula, the one for sine of a sine of b. Go ahead and pause the video, give it a try, and once you have got something, go ahead and unpause and we'll check it together. All right, so let's take a look here. We're going to take sine of a sine of b. Now our a is u plus v over 2. And our b is u minus v over 2. So now we want sine of each of those. And that's equal to half of the cosine of a minus b. Well, we know cosine of a minus b, that was v. So it's going to be cosine of v minus the cosine of our a plus b. That a plus b, that was our u. Okay. And now you can take your 1/2 and multiply 2 on both sides, or you can divide by half to the other side, however you want to say that, and you get the next one. Here, to maintain the same pattern, I'm going to write cosine of u first and then cosine of v. But then you say, well, wait a minute. You just flipped those. Subtraction is not commutative. You shouldn't be able to switch that. That's true. So in order to switch that, what I'm going to do is instead of dividing both sides by 1/2, the way I did for the other ones, here I'm going to divide by -half. That way, the half cancels the half, and the negative makes this a positive and makes this a negative. On the other side, well, I guess I will have to divide by -half, which is the same as multiplying by -2. So this one will have a negative on there. If the result you got was cosine v minus cosine u, and you don't have a negative, that is also correct. But we write it this way because it makes it easier to remember these when you have a nice pattern. All these are u's, all these are v's. -2 sine of u plus v over 2 sine of u minus v over 2. Okay. And finally, the last one, which we would simply find by using the fourth of our product of sum formulas and doing the same kind of substitution. Here we'll just write the result, but all that you would just take this last one that we haven't used yet and do the same thing. We would end up with sine of u minus sine of v is equal to double the sine of, and this is the only one that breaks the pattern a little bit. This negative will be on this one over here. So you'll have u minus v over 2, and then here we have the cosine of u plus v over 2. So that's the only one that breaks the pattern just a little bit here, because here all these are pluses, all these are minuses, but this one's a little bit different. So now let's take a look at some examples of using these sum to product formulas. Our first example, very simple, just like the last examples that we saw for the product to sum formulas. Let's say we have something like sine of 5x minus the sine of 2x. Something like that. Okay. Here, it would be nice if we could just say 5x minus 2x is 3x, but trig functions are not linear. You can't do that. But thankfully, we still have a way of doing that. Here, we've got sine of something minus sine of something. That's our last formula. So here, that's going to be 2 times the sine of. We're going to subtract our two arguments, the 5x minus the 2x, all over 2. And then cosine of, and exact same thing, but with a plus now. So that'll be 5x plus 2x over 2. And so this gives us double the sine of 5x minus 2x. That'll give us 3x over 2. And then the cosine of 2x plus 5x is 7x over 2. And we can change our difference to a product. Now, looking at this example, you might wonder, why would I ever need to do this? Like, okay, I can see what's happening. I plug these in here and it works. But why on earth would I ever want to change one to the other? It's not like it looks any simpler. I mean, it looks different, certainly, but not necessarily simpler. The reason we want to switch is because whether or not something looks simple is not really as important as whether or not it can be used simply for something else. Let's say we had the following problem. We take the sine of 5x minus the sine of 2x is equal to 0. And the question is, we want to find all solutions to this on the interval from, let's say, 0 to 2 pi. Solve on the interval from 0 to 2 pi. So I guess I'm using radians here. Okay? That's hard to do. I could take this and move it to the other side and say sine of 5x equals sine of 2x, and that doesn't make it any easier. This is not easy to solve. But you know what is easy is if I could factor this. If the sum or difference of two things is equal to 0, I don't really have any idea what either of them are. I know these are opposites of each other, but that doesn't really narrow it down very much. This is still really hard to do. But if I were able to factor this, well, yeah, just like an algebra, if we can factor it, then each factor should itself be equal to 0. Oh, but we can factor it, technically. We're not factoring in the traditional sense, the way you do in algebra, but you're still taking this and turning it into the product of things. So this, using our sum to product formulas, becomes 2 times the sine of 3x over 2 times the cosine of 7x over 2 equals to 0. Oh, but now I can solve. Because now it's not an addition or subtraction. Now it's multiplication. Now it's a product. And as we learned in algebra, if the product of things is equal to 0, then either the first one's equal to 0 or the second one's equal to 0. The two can't be 0, so don't worry about that one. So here this gives us two much simpler equations. Sine of 3x over 2 is equal to 0. Or separately, the cosine of 7x over 2 is equal to 0. And that is much easier to deal with. Now, I know we haven't gotten to solving trigonometric equations yet, and we will at the end of this chapter. But here I felt that it was a good idea to mention this because in all of our other sections, we've had examples of, okay, here's how you compute stuff, but also here's how it could be used in some kind of application. Here, these kinds of formulas, it's really hard to show the application physically. The application is We use it to solve equations. So here we'll actually see something like this. We'll see actually lots of things like this at the end of the chapter when we get to solving of trigonometric equations. But for now, it's a little preview of what's to come. Trigonometric functions we will be solving using some techniques that we learned in algebra, things like factoring and simplifying algebraically, but trig functions have their own set of tools that are useful from time to time here. Okay, so that's one kind of application. Here I'm not gonna finish this because again we haven't really gotten to solving trigonometric equations yet, but here each of these would have its own solution, and those would give us our solution to our problem. Let's take a look at another example of something that is an application, but which is something we can go all the way through to the end to, and that is verifying an identity. We've seen some of these before where we're going to be given an identity, and we're going to verify whether or not the statement is true. So here we're going to start with sine of 3x minus the sine of 5x over cosine of 3x plus the cosine of 5x, and that's supposed to simplify down to tangent of x. Now, we don't have any trick questions here. We're not going to be looking at this and saying, well, maybe that's true, maybe it's not. If we ask you to verify an identity, it's true. It's just we want you to show us the steps of how this becomes this. So here, we're going to verify the identity, and we're going to use our formulas here, our sum to product formulas, because that's exactly what we have here. Notice here we've got the difference of two signs. Here's sine of u minus sine of v. That's exactly what this numerator is. So the numerator becomes, so here we're going to say sine of 3x minus sine of 5x. That's equal to double the sine of, now you're going to subtract those two. So 3x minus 5x is negative 2x over 2. And then we're going to have the cosine of, and now we're going to add those two. So that's going to be 3x plus 5x. That'll be 8x over 2, like that. Over, and then our denominator is the cosine of 3x plus the cosine of 5x. And we're going to be using this first formula where the sum of cosines gives us double the cosine of. You add these two. So that's going to give us 3x plus 5x. That'll give us 8x over 2. And then cosine of, and now instead of adding, you'll subtract 3x minus 5x. That's negative 2x over 2. So we started with the most complicated side here. We use the sum to product formulas to turn this numerator into this numerator, this denominator into this denominator. But now we can simplify that further. First of all, the 2's divide away here. And then in here, these simplify down. This gives me sine of negative 2x over x is negative x. The 2's divide away. 8x divided by 2x is 4x. All over. Same thing over here. This is 4x and this is negative x. So cosine of 4x and sine, that should be cosine of negative x, like that. Now, as we saw previously, whenever you have an even function, you can just ignore the negative. Whenever you have an odd function like sine, you can factor out the negative. So this will give me negative sine of x when I factor out the negative. But over here, I don't factor out the negative. I just get rid of it. I ignore it. So I get cosine of 4x times the cosine of x. And now these two divide out. Cosine of 4x divides cosine of 4x. And this gives me negative sine of x over cosine of x. But as we recall the quotient identities from all the way back at the beginning of the course, sine of x over cosine of x is the tangent of x, with a negative out in front. Like that. And that's, well, that's not right, is it? It's supposed to be, oh, you know what? We don't give you trick questions on purpose, but we do accidentally. This is supposed to be negative tangent of x. I just read the problem down wrong. I have these problems written down ahead of time, and I just read it wrong. Here, this one is, yeah, all of this is correct. I just accidentally wrote the original problem incorrectly. So there we go. So this confirms that our desired starting point is, in fact, equal to our negative tangent of x, as we wanted. So this confirms our identity. Okay, so go ahead and give this a try. And I have double checked this one so that I'm not going to write it incorrectly. The question is to verify the identity that the sine of 10x minus the sine of 2x, and let me check, yeah, I'm getting that right, divided by the cosine of 10x minus, oh no, that's a plus, cosine of 2x, and that's equal to, and that one is positive, the tangent of 4x. So give that a try, pause the video, take the time that you might need, and once you're done, go ahead and unpause and we'll go through that one together. All right, so same kind of problem. Here we're going to take the sine of 10x minus the sine of 2x, and that's just this last identity. So I'm going to get double the sine of, you're going to subtract the 2, so 10x minus 2x, that'll give us 8x over 2. And then cosine of, and now instead of subtracting, you're going to add those. So that's going to be 10x plus 2x is 12x over 2. And now in our denominator, we have the cosine of 10x plus the cosine of 2x, which now we're using this first formula. So that's going to be double the cosine of, again, you're adding those, so that's going to be 12x over 2. And then cosine of, and then you're subtracting 10 minus 2, that'll give us 8x over 2. The 2's divide out here. And then these simplify down. I get sine of 8 divided by 2, that's 4x. Cosine of 12 divided by 2, that'll give me 6x. Over, the 2's already divided out, so here we get cosine of 6x, cosine of 4x. But now these divide out. Cosine of 6x divides into itself, like that. And so we end up with the sine of 4x over the cosine of 4x, which, using the quotient identity, as long as these two have the same argument, the sine of that divided by the cosine of that same thing will be the tangent of that same thing. And so this does verify our identity. It does confirm that this does in fact boil down to be just the tangent of 4x. And that is it for this problem as well as for this topic. Kind of a short one. If anybody has any questions, comments, or problems, please let me know. And I hope everyone has a nice day.